Problem 21. Solution for this problem you can find below this video in the reference. The gravitational self-potential energy of a solid ball of mass density ρ and radius r is E. What is the gravitational self-potential energy of a ball of mass density ρ and radius 2r? Solution. From dimensional analysis we can find that this self-potential energy equal to this expression, where beta is some kind of unknown coefficient multiplied by g m squared over r, which by dimensional analysis it has a dimension of energy. Here we don't need to know exactly what is this coefficient beta, because we just need to find how is energy depend from mass and radius. Instead of mass we can put here volume multiplied by density, and we have this expression. Finally we see that self-potential energy proportional to r power 5. It means that if we increase radius twice, energy will increase 32 times. So that's the solution. And the coefficient beta could be found using integration, and that will be 5 over 3. But again, I can mention that in this problem we don't need to memorize this coefficient. Problem number 22. Solution for this problem you can find below this video in the description. A balloon filled with helium gas is tied by a light string to the floor of car. The car is sealed so that the motion of the car does not cause air from outside to affect the balloon. If the car is traveling with a constant speed along a circular path, in what direction will the balloon on the string lean towards? Solution. In this problem, the best way probably is to move to non-inertial frame of reference, which is connected to car. And because this car is moving by a circular path, we have inside of this car centripetal acceleration for any body. So it means that we have to add a frictional force acting on any body inside the car with the frictional gravitational acceleration A. If here is our car and point O is a point of rotation around this car, inside of this car we have force of gravity G and the frictional gravity A going outside of point O, and net gravity will go to this direction. And because our balloon floating in air which is heavier than helium gas, so that will be buoyancy force going outside of this buoyancy force, which is going opposite way to gravity force. It means that balloon will go this way, which is answer D on this picture. And correct answer is D. Problem number 23. Solution for this problem you can find below this video in the description. Two streams of water flow through the U-shaped tubes shown. The tube on the left has a cross-sectional area A, and the speed of the water flowing through it is V. The tube on the right has a cross-sectional area A0 equal 1/2 A. If the net force on the tube assembly is 0, what must be the speed V0 of the water flowing through the tube on the right? neglect gravity and assume that the speed of the water in each tube is the same upon entry and exit. Solution. Here we can use second Newton law. It means that left tube and the right tube, they create the same force on each other during this water flow. It means that in any small period of time delta t, the change of momentum in left tube the same as change of momentum in right tube. And we can write this equation that delta P1 equal delta P2. Now let's rewrite this equation in form of this one. Suppose that speed of water on the left is V1 and we have mass dm1 which is flowing for time delta t through this pipe. So it means that here we had momentum v1 delta m1, and after time delta t we have momentum negative v1 multiplied by dm1. So total change of momentum in this pipe will be 2v1 multiplied by delta mv1. For the same reason, we have the same expression for right pipe. So we have that's equal to 2v2 delta m2. Now let's represent what is delta m1 and delta m2. We have delta m1 equal cross-sectional area in the left pipe multiplied by dx1, which is distance which mass dm1 flowing in this pipe, and multiplied by rho, which is the density of water. Here we have a1 multiplied by delta x1, that's delta volume, and this is the expression for this small amount of mass of water. For the same reason, we have delta m2 equal area 2 multiplied by dx2 multiplied by density of water, rho. So now we can insert this expression for dm1 and dm2 in this equation, and we will get this expression. Here now we can instead of dx1 put here v1 multiplied by delta t, and instead of dx2 we can insert v2 multiplied by delta t. So we have this expression, and now we can cancel several things. We have delta t and rho cancelled for both sides, and instead of a1 we can put a, instead of a2 put 1/2 a, and finally we have this equation. And from here we can find what is v2 compared to v1. This is the answer. So answer is C, correct.